Okay. Hello, can you hear me? Good. Okay, thank you very much for this great opportunity. I've been waiting for this day for years. Seriously. Let me tell you, Jen Chang said this morning he feels nervous about giving a presentation in front of professor. My nervous doubles. Why? I have another advisor. When I was a graduate student, he was in my committee, and when I promote a tenured professor, he wrote a letter for me, and so seriously, I think over the years, my two advisors here, so I'm very nervous. But today, okay, I'm going to not give an academic presentation, okay? What I'm gonna do is report to my two advisors, okay? What I've done over the years, hopefully at the end, they will feel, wow, she's doing pretty good. That's my hope, okay. Okay, I will skip the outline. As you know that I started, I graduated from 1992 as a PhD student. Many of my professional brothers here mentioned that Professor Ho's achievement, particularly like perturbation analysis, okay. I arrived at Harvard almost at end of first stage of perturbation analysis. So there's tons of perturbation analysis techniques, okay? SPA, IPA, you name it, ABCD, 24 letters, at least half being occupied, okay? So to be able to graduate, so I basically look at the alphabetic orders to see what PA I can invite so I can graduate. So when you get into an area, you want to graduate being a PhD student, particularly this area is quite mature. I have to say it's quite a tough job. But luckily, anyway, I got to graduate. Thanks to my two advisors here, they let me graduate. So after I graduated from Harvard, and I have 2 years transition, I went to University of Maryland for a research associate, teaching a flip-flop, but of course, eventually I ended up with University of Wisconsin-Madison in 1994. I decided at that time, I'm not going to do perturbation analysis, because anyway, it's almost done. I don't have a Chris Cassandra's this talent to reinvent. So I would just feel I need to start something new, of course. I did every faculty member you are doing right now are dead, okay, publish papers, and invent my own optimization methodology, so everything seems routine, okay? So I got promoted to be a tenured professor, and later on, 2004, I've been promoted to be full professor, okay? So at that time, I was thinking about, gee, I'm full professor, nobody can say something to me, okay, proposal whatsoever. So I got to do something different, okay? I could do, frankly speaking, I read lots of, at that time I wouldn't be able to call him David, or just Professor Yale's paper, particularly later on his books, unimodularity, all this kind. I feel I'm not that type of person can do that really, really advanced, okay, deep theoretical. It's not I'm not capable, maybe, but I have a lot more broad interest in. And also, the history is so coincidence. I've been working with a company, John Deere, you probably all know in the United States, okay? Particularly like in 2004, they have such a huge supply chain issues. They said, Professor Xu, help us to solve, don't give me papers, okay, solving my supply chain issue. They have 2,000 suppliers. Among those 2,000 suppliers, okay, 60 of them always trouble. Okay, never be on time deliver. Never, okay. So I said, okay, good, they give me money, and they said, okay, my money, some part goes to university, some part I want to develop a product. So we have a company, we have collaborated with someone, but anyway, that's a long story. So that's what I'm going to talk about. So I did, from 2000, since I became a full professor, I took a different route than ordinary full professor, okay? But I think I'm a little bit smart here. I located my academic resource 1/3 doing traditionally, sort of trying to hire my PhD student like Yang Gao here, okay, doing some sort of academic research so they can be academic professor. 2/3 of my students needs to do field trip to really solving real problem. Okay, so that's, I got some SBIR award, and also in 2008, my book published. I did some technology transfer I'm going to talk about a little bit today. And then we have some type of a prototype of system, a prototype like software. Then eventually we are at 2 or 3 years ago, we have really something successful application. Later on, I'm going to briefly mention. And this then we have a huge application starting from 2015, phase 1, 2, 3, and yet today. So my today's story was just basically talking this one. After that, I'm talking some research related in this area. Okay. Now, what I found over the past decade is that manufacturing operations, they're so primitive. Let me give you an example, okay? This is some called National Oil Well Vac, okay? Fortune 500, okay? They have latest like machining and Oracle ERP system and manufacturing execution system. But, okay, for example, they produce something very big, okay? 500 tons and 200 meters high. They have 22 of them this production departments, welding, machining, painting, you name it. And they produce this West New York in Houston. I've been there in the past, I would say 5 years, every month at least twice, at least. My team and I myself, I visited a total of, I think, hundreds of manufacturing forums. So if you don't see me at the Informs or whatever conference, because I'm on the field trip, okay. So for this particular one, for example, if you just take a look a little bit deeper of this kind of RAM cell, okay, they have several machines, very high, capital-intensive machines. But if you look their daily operation, it's based on Excel sheet, okay, developed in-house. Any rush order coming, or machine breakdown, or engineering change, your CNC machine needs to change. They don't know what the impact to overall their sales order. Nobody knows, okay, nobody knows. So they never deliver their products on time. That's one example, okay. Now, I also have an opportunity to work with Boeing. I've been there for many times. Also, one of my team members stayed there for a few months, okay. This is a real, okay, Excel sheets Boeing used to do their daily scheduling, okay. Still, if there's any change, they're just using overtime, okay. Every time, if you're on the weekend, a double salary. If on the holiday, it's triple salary. So they're causing a very high cost. That particularly department I've been in called the major structure department. Another example, this is really sponsored by the company, also by National Science Foundation in the States, okay, is Kimberly-Clark. You all know this facial tissue, those kind of things, okay? And this are few we call subsystem linked together, okay? First one is called a tissue machine, huge 2 tissue machines. Every 10-15 minutes produce different grade of base sheets. Then you have temporary inventory over there to store there, to keep the moisture or prevent the moisture over there. Then you have a winding machine, 12-line winding machine. You have an automatic packing line, then go to warehouse. Almost 100% automation. Only few people forklift for put papers over there. But due to your winding machine could be paper jammed, your upstream here, your tissue machine could be quality issue downgrade, or from A downgrade from D or B or whatsoever. So due to this kind of real-time interruption, any type of interruption, the loss of their the capacity every year sometimes could be 10 to 15%. So the company got to me and said, hey, Professor, we would like to solve the problem. Of course, we have some results, very impressive, which we'll probably have to briefly mention. But overall, you can see that, okay, currently, manufacturing shop floor never be optimized. Not execution optimized. That means in real, anything happen and nobody knows what the impact will be. Okay. So, but on the other side, if you've been working in the scheduling area, we publish tons of papers. Okay, target on scheduling, but there's a huge gap. Okay, the bridge gap took me like more than 14 years. Okay, that's why I stand here today. I wouldn't say I solved the problem, but I made some progress. That's why I would like to report to Professor O and Professor Young. Okay. Okay, now, the system we developed over the years, not only myself, my team member, okay, and the companies and collaborators, partners, some like angel investors along this line, called the manufacturing execution optimization system. Okay, it's based on, of course, like what I call nested partition of the sort of idea, okay? We really have a set of many modules, digital tools, okay, for multi-objective function, okay? Highly configurable, scalable, and full visibility for any decision, your action, you can see the consequence. Okay. Then I do not know how many of you in this room you attend called a daily operation meeting. They're usually fighting. Okay. Some like welding people say, hey, upstream the parts is not here, so I'm waiting for you. The material people say, hey, I need to do a bunch of purchase, otherwise I don't have economic scale. Then downstream says, oh, you don't give me parts, I couldn't process it. They all fighting each other, okay? So they don't have a common platform to communicate, to see whatever action if they are going to do. So we did provide a platform, okay? Also, particularly most important to our group here, we provide decision making in real time, okay? Now, like I said, I don't have time to go through any detail today, but I'll give you overall structure, okay? So we basically has lots of, like this called MES system, where we can integrate them together. We can integrate many ERP systems. Basically, you have lots of deterministic optimization problems here, like a machining shop, heat treatment, fabrication and painting or assembling, sub-assembling. And on this level, it's really simulation optimization problem, okay? Sales order management, the purchasing, work order, data analytics. We also can do supply chain, but no successful example right now, later I'm going to mention. So overall structure, you can see that to make optimization or any scheduling technique to be useful, system needs to be integrated together. They have to add sort of iterate in the real time. Okay, it's really proposed a great challenge to academic community. But to me, like I said, I didn't enjoy my life for past whatever number of years. All my time, I flew out to visit companies. Sometimes the CEO wants to see me. Sometimes the CTO wants to see me. I'm the major force of the product. So I talk to them a lot. But anyway, okay. Now, like I said, there's many scheduling modules. I will have to go through very quickly. That's all related with our area. These are deterministic optimization in the scheduling module. In the planning module, it's about the simulation optimization, because any planning won't be accurate. So we rely on simulation or scenario-based analysis. Okay, they link with scheduling and also link with your supplier. We call production control stage. Okay, so all those three or maybe multiple layers, they real-time connect each other in the platform. And so we can do either shop floor, starting from shop floor going up or from up going down. Maybe saying this are too abstractive, I'm going to use an example to demonstrate how this gets done, okay? Now this, I still come back to this particular example, like I said. This is like in Houston area. I've been there for so many times. I really have to thank for this particularly manufacturing firms. This is a huge company, okay. In Houston, just one side. I still remember the phase one, they give us $200K US dollars, say, do one sale. If you can prove us your product makes sense to me, we're going to continue on, okay. There's a lot of story can be told here, but anyway. So we did a select called the RAM sale, okay, which is something here, over those kind of things. And we try our best. Of course, optimization engine will be there, but overall it's about user interface, about you really learning their schedulers' behavior and all the hidden experience. But this took us about 6 months. But I remember it's in October we have called a report out meeting, and the companies, the managers, shop floor managers, and they all came out. And they said, oh, this looks like pretty good, and improve at least this particular sale, improve their this sale capacity about 10 to 15%. So this is very encouraging. So we wrote another sort of cost proposal, say what phase 2 will cost you. But anyway, so phase 2 will be doing, including more sales, remember, okay, more sales. Of course, we also, we did a great job, looks like, with companies, they also have a team to work with us. By the way, it's not just my student and I, we also have a company working and who develops the product. But anyway, then finally, the phase 3, we integrate with higher level sales, purchasing, and planning, all those kind of things. So I want to show you this one. This is something, okay. This is any typical manufacturing form. You have a plant manager, okay. You have a mass scheduler, or you have many different schedulers for different department sales. You have an engineering support department. They do CNC programming, okay. And also you have production manager, okay. They do different departments like welding and painting or the quality control things. You have a product line because they have 1,000 different products running on the shop on their plant. And you have product line manager, they supervise all those kind of products, everything. You also have a material manager to plan to purchasing, warehouse, and sometimes outsourcing, okay. You also have a quality manager to do specification and keep a document, okay. You also, because thinking about those products is put on the seashore or some big platform, okay, they also have to coordinate with other parts to eventually put over there. So you also have a cooperated program, we call it program manager, project manager. So they are sort of parallel. So everyone right now, today, is using the system, okay. So that's very, very impressive, okay. For example, plant manager will check every day each sales order, whether it will be late, if it's late due to whatever reason, okay, and the cost, okay, due days, and particularly we call manufacturing critical path time, why it will be late, okay. Production VP basically trying to see whether they have enough capacity to meet their demand, and the work order release every day. I won't go through any detail along this line, but here is the results, okay. Particularly this, of course, you reduce inventory, you reduce the cycle time. This number is very interesting. This the main business income. It happens. It's definitely not because of our own product reason, because it happens oil price going down, and they have to lay off someone. So that's plus our product help them to manage their daily operations. So they could have make them, every person the income to be looks. Data. This data is not I made, it's the company people give us, okay. I really want to mention one thing. So our students here, young faculty here will feel very interested about, is number of schedulers. When they first time get into the company to implement, okay, they have 25 shop floor schedulers because they have 22 the manufacturing sales, not the planners, okay. We also reduce planners. Actually, last month they down to 3 scheduler. Right now they're down to 0. So this is really not using robots replace blue collar. It's using advanced technology, optimization technology to replace the white collar. Okay, I would like to give, so the comments from the company, they said that we changed their culture completely. Also some, they are very nice, give us they said it could be game change, but we will see, okay. Okay, so this is something I think is very exciting, news to us. And I remember this just finished, okay, phase 3. Early this year, I was at Houston to heard about all the report out, the results, everything. I heard about the plant manager, everybody, control manager, mass scheduler, talking about how wonderful they are using the system. The one instance I feel they're not talking about my research work because it seems too good to be true. But anyway, I just feel over the past years, so many hard work seems pays off. Now, I would like to switch a little bit about the research issues along the past, okay? And for that particular problem, I mean, the West New York is very complicated. Probably I don't have time to go through detail. I'm using the Kimberly-Clark as to demonstrate how research issues will be closely related, particularly in the industry, in manufacturing area. Like I said, these are several systems. One is tissue machine, okay, and we of course can build. For scheduling, we can build a mathematical formula, and we have wiring machine. And we can also build, and then we can also integrate using inventory. We can also build all those kind of things, and then eventually do lots of scheduling things. Okay, that's just scheduling for daily. Okay, but in reality, this company, because particularly for the writing machine, the speed sometimes is not constant. For thinking about it, when you start writing the papers, okay, the usually will be very slow. Sometimes the paper, if it's too thick, they will be slower. But there is certain interval that will allow your speed to change along this line. So overall, this problem we are solving like I said, is a simulation optimization problem in real time. What do I mean real time? Typically, when they have interruption, they give you a few hours, like usually half day, 3 or 4 hours, to give me a better scheduling or planning, to reshuffling around their original one, eventually to increasing their capacity. Okay, so using this one, actually, we of course facing a simulation optimization problem. How to formulate with lots of formula. I'm not going to go to detail. I don't have time here. And solving the simulation optimization problem in real time. Okay, that's what we are facing. Okay, now fortunately, I have one student here, Xiang Gao. He was working in this area. Of course, that time the Kimberly Clark was just started. Okay, but we, like I said, I smartly located 1/3 of my research effort to theoretical research, 2/3 on the applied one. But I will say those kind of hard work are done by Xiang and another PhD student about new budget allocation. Now, I really want to say budget allocation, of course, started from Jin Hong Chen. He also will mention that for real-time optimization problem, budget allocation is so important because you only have 3 or 4 hours. If you can smartly locate those 4 hours, you will have a competitive edge to get your planning scheduling better than any other your competitors. So I just want to say that. So this, I don't want to talk about this one. Happens to Xiang will talk this work. This paper just being accepted by operations research. Okay, I would like to touch base a little bit about the feasibility. Sometimes the company also facing we need to select a set of solutions when you generate many inputs. Okay, so here in real time so we can formulate the problem by called a feasibility determination allocation problem. So here, as you can see that we want to maximize this probability. Here is one is you identify your design in the correct, which is feasible, okay? Then you reject those design which is not feasible. You want to maximize those kind of probability. Now, there's existing, like I said, fortunately, after my talk, Jin Hong will talking about his research work. He's inventor of OCBA, which is starting a new research area, talking about how we wisely located simulation budget, particularly for real-time optimization. Okay, so in here, you can see traditionally people using equal allocation. Okay, if you give me 10 designs, I equal allocate. Just wrong to pick up the best one. And actually now he created something called OCBA, and also later on some people are using the large deviation. So, but it turns out to be that for feasibility determination, okay, sometimes equal allocation, we could have a theoretical results showing that will be better than existing technology for feasibility. So that makes us to think about how we can design a better allocation strategy. So here comes some theorem. We do not know what's the optimal one at that time, but we could provide a better one, better than current one. That's the theorem 1. I won't go through any detail given the time. Okay, if you are interested in, I have another PhD student. He just graduated. We have a paper we are writing. Hopefully, we can submit to some. We'll submit to some journals. And also, that particular results before we derive the better allocation policy is due to we know the noise is normally distributed. Okay, but if not, we don't even have a closed form formula for this kind of equation. Okay, then actually we develop an approximation of this one is this formula. We have a whole bunch of proof. Like I said, I'm not going to go through proof, and I hope I satisfy Professor Ho's requirement. I don't put more than 3 symbols in the slides, so everybody can. And also this particular example show this one. No, so then after we got the approximation of this original problem, we're solving a relatively easy problem called problem 2, which you want to minimize this one eventually, how to find the budget allocation. Here is we can prove that this one can be solved. So this is the proportion your budget can be allocated for each design. Okay. If you're still curious about what is budget allocation, Jin Hong, my professional brother, will give a more detailed explanation. So I think the session is arranged so perfectly, and then Xiang will give what is opportunity cost, particularly one. So I will be quick. Okay. Okay. So that's about, of course, we still have lots of research issues going on. My timing is perfect. remember, I start from solving supply chain issue, okay? Remember I said with John Deere. I have to tell you that I have solution, but I don't have a successful example to report to you. So I tried, so I will say, I'm in the middle of this one. Yesterday, National Science Foundation of China, okay, just released a call for proposal on digital supply chain coordination theorem and methodology, which I put this one over there. So I'm so glad, and I think why we call digital supply chain, if you think about Toyota production system, at that time for mass production, and then your supplier just put the components in front of your door so you can do assembly. But in digital, eventually, if everything is mass customization, you don't have lots of this kind of inventory to buffer you, okay? Each one is individual one, okay? So we believe the digital, the information, accurate information to make supply chain more lean, and optimal coordination will be future direction. And also, actually, I didn't mention here, I still working with Boeing right now to push along this line using digital technology. We do have technology here. I didn't mention here. I mentioned the manufacturing execution optimization, but that's related another technology around the supply chain part. So I'm so glad that yesterday someone just emailed me and said, "Oh, Professor Shi, the call for proposal just came out, which is National Science Foundation of China, jointly with China Aerospace Science and Technology, the bigger corporation, okay, for this one." I think that's pretty much all my report to my two advisors. And I think down the road, as you can see, that a lot more can be done. And for the young faculty, you have lots of research that can be accomplished here. So I will stop here to take any questions you might have. Thank you.
So thanks for Professor Shi's talk, and I was always be inspired by her passion to find the real and have impact problem. Okay, I think due to time limitation, I think we can have only one quick questions. Okay, professors.
I want to make one statement and then another question. The statement I hope won't embarrass you something about Leyuan that most of you don't know, and compared to all the success you have, but that's actually not surprising to me, because in 1992, when you were admitted directly from China to Harvard, you were
1987.
1987, you graduated.
I graduated in 1992.
Yes, correct.
Yes.
87. You arrived Harvard 6 weeks late out of the 50-week semester. And a lot of people said, we can't let her. She can't catch up, we will fail. And because she was giving birth to her first baby, and China won't let her leave. So she stayed back alone to recuperate correctly for 6 weeks. Then arriving in a new country with a new system of education, language problem, being a mother, and she not only survived, she excelled. So I'm not surprised with all the success now you have. So.
Thank you very much.
Now my statement is, I just came from the CASE conference, the Automation, Science, and Engineering in Xi'an International Conference 3 days ago. Well, in fact, concluded yesterday when I left. And one of the questions which I raised, and I hope people give an answer, and I want to raise it again here. Because one of the numbers in your slides caught my eye. You said the Houston company had 25 schedulers. Now they have 0. Now these 25 guys lost their job forever. It's not because of recession. They temporarily lose, they will be hired back. Their job has been replaced by automation.
Yes.
So we are in an area, 200 years ago, we have the Industrial Revolution, where a lot of muscle power has been replaced by mechanical power. Now we have the intelligence revolution. Lots of middle class, routine intelligence jobs are replaced by software. Now, this is a problem not worrying any of us here, because we're educated in this. We are beneficiary. But there's a lot of indications, from various sources, like in the next 30 years, 50% of the jobs in the United States will disappear forever, never come back. And those people are beginning to feel all these problems. In China, somebody even predicts 70% of the job will be replaced. And all these people need to live. They used to enjoy middle-class life. Now, their futures basically are disappeared. And this will cause tremendous anger, tremendous social problems. Election the last year in the United States was manifestation of this, and there's going to be all kinds of problems. So even though we're the beneficiary of this intelligence revolution, we have to be concerned about those people who are not and become victims, and how to solve this problem. Both we as a participating in this revolution, as well as the government. So I just, I don't have any solutions. I like to hear people's, and particularly your real life experience, what happens in situations like this.
Well, actually, this kind of problem, particularly in China, would be probably more severe. And in government-owned company, okay, they want to stabilize the society. So they say you cannot fire anybody.
Yeah.
Then my solution may not be good. I said, why you let the people working for 5 days? Why not working for just 2 days? Then you're so happy. And you can relax, fishing and watch movies. And why everybody work for 8 hours, you work for 3 hours. So I think there's a tremendous opportunity for the society to think about it in the more positive side. That's just my 2 cents.
Good.
Okay, thanks.
I agree. I mean, like 16 hours per day. Thank you very much.